This is Algebra Lesson 5-5, Standard Form. Now we have done slope-intercept form, we have done point-slope form, so now this lesson we're going to take a look at standard form. Standard form of a linear equation is an equation in the form of ax plus by equals c, where a, b, and c are real numbers, and a and b both cannot be zero. One of them can be zero, but both of them at the same time cannot be zero. The x-intercept is the x-coordinate of the point where the line crosses the x-axis. Remember, we've used the y-intercept before. That's the y value of the point where it crosses the y-axis, excuse me. So the x-intercept is the x-coordinate of the point where it crosses the x-axis. So the standard form of a linear equation allows you to find intercepts very, very quickly. And you can use those intercepts to draw a graph, as provided the intercepts are whole numbers. So the slope-intercept form of an equation is just one form of linear equations. Another form is standard form, and standard form is often very helpful for making graphs, especially ones that are dealing with real-world situations. So if we're going to find our intercepts, the thing that you need to be aware of is to find your x and y intercept, to graph a linear equation in standard form using your intercepts. To find your x-intercept, you let y equals 0 and solve for x. And to find your y-intercept, you let x equal 0 and solve for y. Essentially, you let the opposite variable equal 0 and solve for the variable that's not 0. So let's take a look at that. So find the x and y-intercepts of each equation. Now, I like to do it a little differently than some teachers do, because I find it's often easy if I make myself a little table of values to help my brain remember what I'm supposed to be doing. So I will oftentimes get a little x and y table here, and I'll say, oh, what happens when x is 0, and then what happens when y is 0. And then I just solve it. So if x is equal to 0, 3 times x is going to be 0, plus y is equal to 12, which means y is equal to 12. Okay, so to solve for our y-intercept, we let x equal 0 solve for y. So y here is 12. To solve for our x-intercept, we let y equal 0 and solve for x. So we'll have 3x plus 0 times y is 0 equals 12. To solve this, divide by 3, which means x is equal to 4. Now, it's very important that you know how to find your x and y intercepts from this lovely little table that I just made. It's really, really critical that you understand that you need to use your intercepts as coordinate points, not just one value, but both the x and the y value, because then you'll graph them better. So if I'm going to give you the x-intercept, that is the point on my little table where there's a value other than 0 in the x position. So that would be this one down here. So my x-intercept is 4, 0. Meaning my y-intercept then is the point where there's a value in the y position other than 0, which would be 0, 12. So my x-intercept is 4, 0, and my y-intercept is 0, 12. Let's look at example 2 here. So example 2, I'm going to do the exact same thing as I just did. I'm going to make a little x and y table. What happens when x is 0? What happens when y is 0? When x is 0, x goes away completely. So I have negative 3y equals 9. Divide by negative 3, divide by negative 3. Y is equal to negative 3. When y is 0, that means y goes away completely. So if y goes away completely, I have negative 4x equals 9, because y goes away. Divide by negative 4, divide by negative 4. X is equal to negative 9/4. And it's okay if it's a mixed number. You can leave it as an improper fraction, or you can leave it as a mixed number. It doesn't matter to me. So again, make sure you know which one's the x-intercept and which one's the y-intercept. So my x-intercept is the point negative 9/4, 0. And my y-intercept is the point 0, negative 3. Always list them as coordinate points, because that way you'll be more likely to graph them correctly. Last example here. I'm going to do the exact same thing I've been doing all along. I'm going to make my little x and y table. What happens when x is 0? What happens when y is 0? When x is 0, basically that means this goes away. That's what I mean by it goes away, because anything times 0 is 0. So I get 2y equals negative 6. Divide by 2. y is equal to negative 3. Now, when y equals 0, that means y goes away. So I now have negative 3x equals negative 6 divided by negative 3, and x is equal to 2. So my x-intercept would be the point 2, 0, because it's the point where there's a value in the x position other than 0. My y-intercept is going to be 0, negative 3. And I have found my intercepts. Now the handy-dandy thing about intercepts is once you've found your intercepts, it makes it a little easier to graph your equations. Right? Once you have solved an equation for the x and y intercepts, it's rather easy to graph, provided that the intercepts land on a coordinate point. If they land on some obnoxious fraction like 3 1/17, you are not going to use the intercepts. If it lands on something like 3 1/2, yes, you can use a half. A half is pretty easy to graph. Some people can even graph quarters or thirds fairly accurately. Okay, but if it's not something that's really easy to figure out, then you're not going to be able to use an intercept to graph it. You may have to go back to drawing a table, making a table of values, or perhaps using slope-intercept form. All right, so once you've found the intercepts, you just graph those 2 points, draw your straight line, and label it. So we're going to graph using intercepts the following 2 equations, 5x plus 2y equals negative 10, and 2x minus y equals 6. So this first equation here, I'm going to simply do my little x and y table like I've been doing. X is 0, y is 0. If x is 0, that means it goes away. So I have 2y equals negative 10. If x goes away, 2y equals negative 10. Negative 10 divided by 2 is negative 5. Eventually, you should be able to do some of these in your head. If you cannot do them in your head, show the work so that you don't make a mistake. If y equals 0, that means y goes away. And I have 5x equals negative 10. Negative 10 divided by 5 is negative 2. So my x-intercept is negative 2, 0. And my y-intercept is 0, negative 5. So I'm going to plot those 2 points. Those are the 2 points I'm going to plot on my graph. Label my x and y intercepts, very, very important. My x and y axis, excuse me. My x-intercept is negative 2, 0. So here, negative 2, 0 is there. My y-intercept, 0, negative 5. 0, negative 5 is here. Use my lovely straight edge to make my straight lines. Okay, please use your straight edges. Connect them with a straight line, just like that, and then label it. So I'm going to label it 5x plus 2y equals negative 10. Graphing by intercepts is marvelous, provided your intercepts are whole numbers. If they're ugly fractions, you're not going to be able to use intercepts. And problem number 2 here, I'm going to do my x and y table again. If x is 0, if y is 0. If x is 0, you get negative y equals 6, so that means y is going to equal negative 6. If y is 0, you get 2x equals 6, that means x is going to equal 3. So my x-intercept is 3, 0. My y-intercept is 0, negative 6. Those are the 2 points I'm going to graph on my graph. Those are the 2 points I'm going to plot. So I'm going to plot the point 3, 0. So 3, 0 is here. Negative 0, negative 6 is down here. Take my handy dandy straight edge. Connect these with a solid line. Making sure it's fairly accurate in case you have to just adjust just a little like I do. And then label your equation. 2x minus y equals 6. I actually really enjoy graphing by intercepts. Sometimes it's easier, sometimes it's not. It depends on if my equation is written in standard form or written in slope-intercept form. Now, there's some other important information that you need to pay attention to. If a equals 0 in the standard form of ax plus by equals c, then you can write the equation in the form of y equals b, where b is going to be a constant, like y equals 6, or y equals 2, or y equals negative 4. If b equals 0, you can write the equation in the form of x equals a, where a is a constant, like x equals negative 2 or x equals 6. The graph of y equals b is a horizontal line, and the graph of x equals a is a vertical line. You need to memorize these. You need to know which one is which. So when you're going to graph horizontal and vertical lines, if you know which one is which, they're not hard to graph. If I look at this first problem, y equals 5. It's in the form of y equals b, which means it is the graph of a horizontal line. Basically, it's saying this. Okay? For all values of x, y will equal 5. That is what this is saying. For all values of x, y will always equal 5. So no matter what value I choose for x, y is going to be 5. So if I chose 2 for x, y is 5. If I chose -6 for x, y is 5. So it ends up to be a horizontal line here at 5. All right, now, whoa, that was not very horizontal, was it? Let me rewrite that, draw that. That's better. The one thing that's really, really important is if I didn't use colors, if I would have used black and it would be the same color as every other line on this piece of graph paper, it would be very hard to differentiate which one is my horizontal line and which one's my x-axis, which is why it's really, really critical that you label your axes and you label your equation. Okay, so there we have our equation written and we've labeled our axes. If we look at the second problem here, we have x equals -4. It's in the form of x equals a, which means this is a vertical line. Since it's a vertical line, it means for all values of y, x is going to equal -4. It doesn't matter what y is, x will be -4. So if y is 0, x is still -4. If y is 4, x is still -4. Okay, which means this is a vertical line. So we're going to draw a vertical line at -4. And of course, we're going to label our x-axis and our y-axis, and we're going to label our equation, x equals -4. Once you understand the form for a vertical line, the equation of a vertical line and the equation of a horizontal line, and you memorize which is which, then it's really, really easy to graph them. It is often helpful to be able to change an equation from slope-intercept form to standard form or from standard form to slope-intercept form. Now, when changing from slope-intercept form to standard form, you absolutely must clear all fractions and decimals. You must have it written in standard form, always requires you to write it in integers. Okay, you write the equation using only integers. So if I needed to transfer the following 3 equations to standard form, okay, first thing I'm going to do is I normally clear my fractions first. So if I look at problem number 1 here, I have y equals 2/3 x plus 6. I don't need to get rid of the 2/3. I just need to get rid of the denominator. So don't think you have to multiply everything by 3/2, because if you do, you're still not going to get rid of your fraction. So you just need to focus in on the denominator. Okay, so if I take this equation, and I'm going to multiply everything in this equation by 3. So if I distributed that 3 times y is 3y, equals, if I multiply 3 times 2/3, that becomes 6/3, and 6/3, it happens to be 2. Okay, so that equals 2x, and then 3 times 6 is 18. Now we're almost in standard form. We're not completely in standard form, because remember, standard form is ax plus by equals c. So we have to move the 2x from this side of the equation to the other side of the equation, so we need to subtract it. So if we subtract it, we're going to get -2x, maybe, if my pen will write. Well, my pen's not writing all of a sudden. -2x, hello, pen. It does not want to write all of a sudden. -2x. I am going to have to pause this video to fix my technical difficulties. Okay, my pen is not working, so we're going to use my finger for the rest of this, so the handwriting is going to be terrible, but just bear with me. So we took this equation, 3y equals 2x plus 18. We need to move the 2x over, so we subtracted it. So the next thing I'm going to do here is, once we've done that, you have to write it in the correct form. So we're going to have negative 2x. This is going to be fun because I'm going to have to draw with my negative 2x plus 3y equals 18. And we can leave it in negative 2x plus 3y equals 18 form, or if you really like to have your equations so that the first term is positive, this would be a positive 2x, or I'm not going to write the positive sign, I'm just going to write 2x. So this would be 2x. You have to change all the signs. So this would be 2x minus 3y equals negative 18. And this is taking a lot longer to write with because it's really hard to write with a mouse. So I apologize for the ugly handwriting. Okay. So it doesn't matter. Either one of those would be fine as long as you can figure out what it says. All right, the second equation here. If you look at this equation, again, I'm going to need to clear my fractions. All right, and if you want to, you can clear the negative sign at the same time, but I'm not going to. I'm going to multiply everything by 5 here. So I'm going to end up with 5y. If I distribute that 5 through there, I'm going to have negative 2/5 times positive 5 is going to end up to be negative 2x. And then 5 times 1 is 5. And then, of course, I have to get it in standard form, which means I have to get the negative 2x to the other side of the equation. So we're going to add 2x to both sides of the equation. And by doing that, we will end up with 2x is plus 5y is equal to 5. And we have that equation. Number 3, I would like you to try on your own, see if you can get that correct. So please try number 3 on your very own. Make sure you do your best to try it. I will look at it in class and see how well you did. All right. Now let's use standard form for a model. In other words, we're going to look at it and we're going to try to answer a question based on a real world application. So a media download store sells songs for $1 each and movies for $15 each. You have $60 to spend. Write and graph an equation that describes the numbers of songs and movies you can purchase for $60. Okay, so let's take a look at this. So considering the fact that I'm going to have to write a lot here, I'm going to actually write it in typing form because it'll be easier for me to do and it'll be easier for you to read. So we're going to put this here and I'm going to put all this stuff in here that I would be writing by hand if I actually had a pen that worked with my Surface today, but it's not working. So I'm going to do this in lovely purple color because I like purple. This would end up to be the cost of your song, okay? Because we have to figure this out. In standard form, the cost of my songs times the number of songs, okay, plus the cost of a movie times the number of movies, and I'm going to abbreviate that, should equal a total of $60. Okay, the cost of the songs times the number of songs, and the cost of my movie times the number of movies I download cannot exceed $60 because I only have $60 to spend. Okay, so I need to define some variables now. So I'm going to define some variables here as well. So if I define my variables, I'm going to have, I want this to be purple again, My variables are going to be, I'm going to let, oh, that's not where I wanted that to be. I wanted it to be over here, so I'm going to have to do that again. Didn't like me doing a couple of things there. I'm going to let x equal let x equal number of songs, and I'm going to let y equal number of movies. So now my equation is going to be the cost of my songs. Okay, songs were $1 each, times the number of songs, which in this case happens to be x. So here, this is going to be 1x plus, now I have got my cost of my movie. Well, movies are $15 each, times the number of movies, which is y, has to equal 60. Now you know why I typed it, because my handwriting with a mouse is not very good. So now I need to find my intercepts. Okay, so I'm going to do my little x and y table over here. Oh, that's a terrible y. Let's try that again. It's much easier to write with a pen than it is to write with a mouse. All right, so if x is 0 and if y is 0. Well, if x is 0, we have 15y equals 60, which means y is going to be 4. If y is 0, then we have x is equal to 60, so x will be 60. So our x-intercept is 60, 0. This is our x-intercept. And our y-intercept is 0, 4. That's our y-intercept. So I'm going to plot those points on my lovely piece of graph paper here. So if x is 0 and y is 4, I'm going to have a dot right here. And if x is 60 and y is 0, I'm going to have a dot right here. And of course, I'm going to have my line I need to draw here. So there's my lovely point here. Now, interestingly enough, even though this is a linear equation, and even though I've made it as a continuous graph, because it is, we obviously know that the only points that are going to work are whole number points. Okay, I can only have whole number points. So if I'm going to use red here to make my dots, I can have a point here because it lands on an intercept. Whoops, don't want that. I just wanted this to be this way, sorry. Okay, I can have a dot here. I can have a dot here. I can have a dot here, because I can't have half of a song and I can't have 2/3 of a movie. So even though we draw the line to show that and make it look like it's continuous, because that's how we connect our points, okay, we do know that this is a discrete graph, because the value of the purple stuff between the red dots doesn't mean anything, because you can't have 2/3 of a song. I mean, if you have 2/3 of a song, you're kind of sad because you only have part of the song. You don't have the whole song. All right, so let's review a couple of things here. Linear equations can be written in many different forms, with each form having its benefits and its drawbacks. We have slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. And I give you an example like y equals negative 2/3 x plus 5/3. We have standard form. Okay. Standard form for the same exact equation would be ax plus by equals c, where a and b are both not 0. So in standard form, that equation would be, or an equation would be 2x plus 3y equals 5. Or we have point slope form, y minus y1 equals m times x minus x1 form, where x1, y1 lies on a graph and m is the slope, like y minus 1 equals negative 2/3 parentheses x minus 1. Each one of these forms has both benefits and drawbacks. So that's why we need to know all three forms, because in different times you will need to do different forms. Okay, our closure question for today. How can you determine the x and y intercept of a linear equation written in any form? How can you determine the x and y intercept of a linear equation written in any form? Please answer that completely as your closure question.